Okay. We have charge. What is charge? Well, in the context of electricity, mostly the charges that we are measuring are electrons. Okay? You guys know that there are other charges. There are protons. There are ions. Yes? But mostly what we're looking at in electricity is electrons. And what do you guys know about the size of electrons? They're like so small. Yes? So small, we cannot count them one by one. You would be here from now till the end of time, counting electrons one at a time. So, what we will often do in electricity is we will grab almost like what we're going to call it a bucket of electrons. Okay? Now, is there a literal bucket? No, there's not. It just means a big number of electrons are contained in each bucket, and each bucket contains the same number of electrons. Okay, so each bucket contains the same number of electrons. And what is that number? It's a really big number. It is, if you've done anything with scientific notation, it is 6.24 times 10 to the 18. If you've not done anything with scientific notation, that is 6.24 quintillion electrons. So like, you know how you have a million, a billion, a trillion, a quadrillion, a quintillion. Okay? So I can't even begin to envision how many that is. It is too many. But if we were to write it out with all of the zeros, what we would have is we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros, and then we would have these two extra, and that's where we get that 18 from. Okay, when we have 10 to the 18. That's a lot. Okay? So, rather than trying to envision this number of electrons, which is pretty much impossible, what we're going to do is we're going to call it a bucket of electrons, but we're not going to literally call it a bucket. There is a real name for this number of electrons, and that is called a coulomb. Okay? It's loam, like it's pronounced like comb at the end, you know, a C-O-M-B, a comb. And the C-O-U is cou. Okay, so it's like coulomb. So a bucket of electrons is 1 coulomb of electrons. Is good? Okay. But I will still sometimes refer to them as buckets of electrons. So you can picture just, you know, someone grabbing a bucket and each bucket contains the same number of electrons, which is just like a whole huge heck of electrons. So this is charge. And the abbreviation for Coulomb, because Coulomb is the unit, Coulomb is the unit, and we like for units to have abbreviations because otherwise we have to write out the whole word every single time. And can you guess how we abbreviate it? The letter C. And this is actually named after Monsieur Coulomb, who was a Frenchman. And so because it is his name, that's a capital C. And so the abbreviation is 1 Coulomb. That is a capital C. Okay, capital C. So what we can think of this is a Coulomb is a bucket of electrons. And Coulombs, a Coulomb is the unit for the quantity charge. So basically we're counting up the amount of charge, but instead of going 1 electron, 2 electrons, 37 electrons, 424 electrons, 1,000,001 electron, 1,000,002, 5,346 electrons. Instead of doing that, we go 1 Coulomb, 2 coulombs, 3 coulombs. Okay? So just like last day when we had distance and time, today we have charge and we have coulombs. So the quantity that we are measuring is charge. And the symbol for charge is Q, which might not make a lot of sense, except that Q is the symbol for quantity of charge. It is the symbol for charge. The unit is the Coulomb, and the abbreviation for Coulomb is the letter C. So we've learned what charge is. That's our first electrical concept. Our second electrical concept is current. Have you guys heard of electrical current before? Yes. Electrical current is basically just the rate of flow. So there is electrical current, there's current in a river, right? So it is just how fast something is flowing. So here we have a little picture of a river, okay? And there is a current in that river. And in theory, if we wanted to measure the current of that river, we might count the number of buckets of water that pass a certain point. We might sit on this rock here with our little stopwatch. Okay, and we might look and we might say, how often let's see, I've got how many buckets go across the river. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 buckets go all the way across the river. And every second, one of those rows of 11 buckets goes past. So my current would be 11 buckets per second. Does that kind of make sense? Okay. I mean, nobody's going to actually sit there and do that with buckets of water, but we can imagine. Now we're going to be looking at, instead of the flow of water, we're going to be looking at the flow of charge. Okay, so we're looking at our current in charge. So this is electrical current. And once again, the symbol doesn't make a lot of sense. Wouldn't it be nice if current, the symbol were C? It's not. The symbol is I. So we have current, but its symbol is I. And if you need help remembering that, do I have it here somewhere? Oh, it's probably down below, but we're going to write it here anyway. This stands for the intensity of the current. Yeah. So we have the intensity of the current. The unit of current is called the amp. Which is actually short for amperes, which is another Frenchman's name. I guess the French were really into electricity at one point. Monsieur Ampère. Okay, that was it. And so the abbreviation for that is the letter A. So current, which is represented by the letter I, is the rate of flow of electrical charge. And what's the symbol for electrical charge? Q, because remember, what does the Q stand? It stands for the quantity of charge. And Q is measured in coulombs, or buckets of electrons. So here's our little analogy of a river. If we are measuring the current in a river, we measure it by seeing how much water passes a point in a second. And our units for that could be buckets of water per second. If we translate that into electricity, current in electricity is represented by the letter I. Remember, that stands for the intensity of current. I should put a capital I there. So instead of how much water is flowing, it's how much charge passes a point in a second. And the unit for that, if we measured water past a point in a second, that's buckets of water per second. If we measure charges, that's buckets of electrons that go past in a second. And what is our true word for a bucket of electrons? A coulomb. So we are measuring the coulombs that pass a point in a second, and we can abbreviate that as coulombs per second. So the unit of current is coulombs per second. But hang on. Let's go back up for a moment. What was the unit of current? Was the unit of current coulombs per second? It was amps. Do you know what that means? It means that amps are coulombs per second. So what we're doing is we're taking the unit coulomb per second and we're simplifying it into a shorter unit. Okay? So a coulomb per second is the same as an amp. So 1 coulomb per second is equal to 1 amp. If we had 15 coulombs per second, that would equal 15 amps. There are two ways of writing the same unit. Will we be doing an example?
No.
Oh. You're asking, are there any other ones where we simplify the unit like that? Yeah, there are. In fact, there's a whole ton of them. For example, we're going to learn about a joule, which is a unit of energy. And to be honest with you, joules are actually kilogram meters squared per second squared. You don't need to know that, okay? But if you break it down into its component units, it's crazy, right? This is actually how I got through physics, is knowing what units equaled what other units. And a Newton is a kilogram meter per second squared. Do you see how those two kind of look similar? So this is a measure of force, yes? And this is a measure of, oh, hang on, did I do that wrong? No, it's meters squared per second. Yeah, meters per second squared, sorry. This is a unit of energy or work. You totally don't need to know any of this. I'm just doing it because I'm geeking out a little bit, okay? So you can just ignore me if you want to. So we have energy and we have force. And the only thing different about them is that this doesn't have a little square there. Do you guys know what squares are? Like it would be like, if you had 3 squared, it would be 3 times 3. Yeah? Yeah. So if we had meters squared, that's meters times meters. Okay? So interestingly, work is equal to, here's another formula, force times distance. And if you take your force, which is kilogram meters per second squared, and you multiply it by distance, which is in meters, you end up with kilogram meters squared, because you got meters times meters, per second squared. And the units, if the units work, then you know the formula is going to work. Anyway, crazy stuff. Yes? A lot like that, yeah. Yeah. So it's pretty cool. Like, and if you can kind of get the hang of that in like physics 11 and 12, it really takes you a long way. So units are so important if you're doing physics and chemistry as well, actually, to be honest. All right, I'm going to get rid of that though, because I think it's a little terrifying probably for some of you because you're not there yet. And you don't need to be. Okay. Now, this is our first electricity formula, and this is the I quit formula. Do you remember that one? We looked at it a few days ago. The I quit formula. I equals Q over T. And so if we go through all of these, that means that current, which is I, is equal to the charge, which is Q, over the time, and we've already done time, so I haven't spent any time on that, is T. And then we can look at what is the quantity. The quantity is current. The symbol for the quantity is I. The unit for that quantity is amperes or amps or coulombs per second. And the abbreviation is either amps or coulombs per second. Charge is equal to Q. Q is the symbol for charge. It is measured in coulombs, and the abbreviation for that is C. And then we have finally time. We know that that's abbreviated T. The unit is seconds, and that is S. And we're now going to use this formula, I equals Q over T, to use the Guess-Cubs method of solving the problem. What does G stand for? Actually, before we do this, what does G stand for? Given. What does U stand for? Unknown. What does E stand for? Equation. How about the first S? Solve. And we're solving for the unknown. And we're not doing that yet. We'll do that tomorrow. Okay? Solve for the unknown. And then our second S, substitute. What comes after guess? Cubs. We got C-U-B-S. What does C stand for? Calculate. And that means you're probably either going to do that calculation in your head or grab a calculator. Yes? Depending on how hard it is. What does U stand for? Units. Make sure your answer has units. Make sure your answer is in a box. And make sure you stop at a reasonable number of digits. Or if you want to do the enriched one, you can do sig figs. And if anyone isn't interested in the sig fig enriched material, it is now at the back on the table by the door. So anyone wants the enriched stuff on sig figs, it's back there now. Anybody want to go get one now? I'll give you guys a minute. If you want to go get one, go get one. If you don't, that's fine. We could get the dividers. We're going to do it together. We're going to do the examples together, but if you want to work ahead, just feel free to work ahead. Okay? Okie dokie. Shh. So we are now on page 32. Feel free, if you're like, wow, Ms. Spence, I totally got how to do this, 2 days ago. Feel free to work ahead. You can pace more quickly, but I'm going to do it with you just because, you know, it's been 2 days and you only did it for the first time on Monday, so let's give it a try together, or Tuesday or whenever it was. All right, so we look at our question, and in order to get the given, we look for the numbers. So we have one number here, and we have one number here. What quantity are we measuring when we are measuring coulombs? Coulombs measures charge. What is the symbol for charge? Q. So what we're going to do for our given is we're going to write Q equals 12 coulombs. Do you guys think you could do the second quantity on given quantity on your own? Do you want to try it? Okay. Okay, and if you got stuck, time is what is measured in seconds, and its abbreviation is T. So we're going to write down our second given, T is equal to 4 seconds. So when we're looking at our given, we're looking for numbers. What do we look for when we are looking for our unknown? When we're looking for the unknown, we look for the question words. Can you guys think of some question words? What? How much? How long? Yes? Any kind of question word like that, and that's going to tell you what your unknown is. So where is our question word in this question? It says, what is, and what are we looking at? We're looking at the current. Oh yeah, and they're in that box there. Sorry. The scrubby things? Okay. So for our unknown, we're going to say, oh, what is the symbol for current? Symbol for current is I. So we're going to write I equals, and then we can write we don't know. And if you happen to know the unit for I, you can also put the unit there to remind you. What is the unit for current? A, amps. Okay? So we have our given, we have our unknown, and next we have our equation. Now, if you look at the purple sheet that I gave you, okay, everyone grab your purple sheet and take a look at it. Which of these equations would you use if you have I and Q and T? You're going to use I quit. Yes? Now, the nice thing about this worksheet is you're only going to be using I quit. That's the only one we've learned so far. Okay? So we're going to use I equals Q over T. Now, if we want to solve means we want the unknown by itself on the left. And our unknown is I, and we want it by itself on the left. Is it by itself on the left? Yeah, it is. There it is. Okay. And I'm just going to rewrite the equation here. I equals Q over T. And then we are going to substitute, which means for Q, we're going to take 12 coulombs. For T, we're going to take 4 seconds. That should be a little less, not a big S. I don't know what I'm doing. There we go. Let's make that a little less. So that was substitute. What comes after substitute? We've done guess. Calculate. You could probably do this in your head. What is 12 divided by 4? 3. And our unit now is coulombs over seconds. And you could actually leave the answer like that, and that would be okay. All right? Or, what's the other way to write the unit of current? 3A. And then you would put a box around it. We have our units. We have our box. And have we stopped at a reasonable number of digits? Yes. If we wanted to do significant figures, how many sig figs in the number 12? 2. How many sig figs in the number 4? Just 1. Okay? And so that would give us 1 digit, so it would be the same. And now, you guys can start some exercises here. Okay? So we're going to do pages 33, 34, Yeah.